symbol here, sort of a largish S type symbol, means anti-differentiate or integrate, or find an indefinite integral. I'll talk more about that in a little while. So it's the opposite of differentiation. Okay, so if you look here, we've got an expression here, f of x equals 3x squared plus 7x plus 5, and when we were doing differential calculus, we learnt that the derivative of that is 6x plus 7. Okay, so we've done that before. So, what if we had to find the antiderivative of 6x plus 7? That is, we are at this stage here, okay, we've got the derivative, but we want to find the original equation. Use that sort of language. That's what anti-differentiation is. Having a derivative, a gradient function if you like, and finding the original function. Okay, so to do that, here's the answer. Alright, and I'll show you how to do it in a moment. But that would be the original function of 6x plus 7. Now what's this plus c button? Okay, well if you relate things together here, you can see that the derivative of 3x squared is 6x. The derivative of 7x is 7. But there could well have been, let's rub this out for a moment, there could have well have been another number here, okay, that's the plus c, it's a constant, it's a number that we don't know of, because the original could well have had a number there that when you get the derivative of it is 0, because as you know, the derivative of a number, constant like that, is 0. So when we, if I undo a few bit there, when we give the antiderivative, okay, the integral, if you like, of 6x plus 7, let's get it back to the way it started. So the integral of 6x plus 7 with respect to, that's what that means, respect to x, it's 3x squared plus 7x, plus there could have been a number that we don't know, because when we get the derivative, of course it equals 0. So that's where the plus c comes from. So when you get an antiderivative, you always put the plus c there. So here's some rules. Okay, so we know that the derivative of f of x is f dash of x. So the integral of f dash of x with respect to x is f of x. So they're reverse processes. Okay, the reverse of each other. The integral of a dx is ax plus c. For example, the integral of 5, okay, equals 5x plus c. So this is where we're getting our mind around. We're used to differentiating, okay? So the derivative of 5x plus c would be 5, okay? Because the plus c being a number is 0, and the derivative of 5x is 5. Okay, the derivative of, the integral of ax to the n dx is a times x to the n plus 1 over n plus 1. So coefficient out the front, raise the index by 1 over the new index. That's how you'll hear me explain it a lot of the time. Coefficient that is out the front, x raised by a power over the new power, and of course we've always got the plus c, and because we can't divide through by 0, n is not equal to negative 1. Let's practice using, before I go into the other rules, let's practice using that first rule. Okay, so the integral of 2x plus 7. What's the original equation? 2x to the power of 7. The derivative is 2x to the power of 7. What is the original equation? So that's what you're doing. You're anti-differentiating. You're getting a derivative and going back to an original equation. So you might notice we're going to use this rule here. Okay, so scribble all over it now, but oops. Copy this over to here. So we're going to use this rule here. I'll just leave it off to the side, like so. And I might just some of this stuff here as well. Neaten it up a bit. Okay, it's close enough. So let's apply this rule. So what the rule says is that if we get the antiderivative here, it's going to equal 2 sits out the front, x to the power of, we raise the power by 1 over the new power, over the power of 8. Okay. So that's going to equal, if we cancel 2 and 8, 4 and once, okay, we get x to the power of 8, x to the power of 8 on 4, and we mustn't forget either time our plus c. So there's our answer. Next example, integral of 4x to the power of negative 3. So here's our rule over here once again. There it is. And let's apply it here. So it's going to equal 4, sits out the front. We've got x, we raise the power by 1, so it's to the power of n plus 1. Okay, the original power is negative 3, we raise it by 1, we get negative 2 over the same power. So negative 2 on the bottom. Excuse me. So 4 divided by negative 2 is negative 2. X to the power of negative 2. And not forgetting our plus c's as we go. And that's going to equal negative 2 on x squared if we take the x to the power of negative 2 to the denominator plus c. So there's our next example. Next one. Square root of 3 over the square root of x dx. We're going to change that straight away to the square root of 3x, sorry, square root, the integral of 3x to the negative a half dx. I can sit there. Okay, equals 3x raise the power by 1. So negative a half, let's do it over here, negative a half plus 1, okay, is a half. Hopefully we can work that out by now. Okay, so raise the power by 1, so it's x to the power by half, over a half plus c. When we divide anything by a half, we're actually effectively multiplying by 2. So now we get 6x to the power, x to the power of a half plus c. And x to the power of half is square root x, so it's 6 root x plus c. There's another example. Next one. What we'd have to do here first is remove the brackets. Okay, so we get 3x squared plus 5x minus 3x minus 5 bracket dx. Okay, so that's going to equal integral, if we collect like terms, 3x squared plus 2x minus 5 dx. So here we get the derivative, get the antiderivative of each piece of this here separately. So effectively what we've got, if you like, is the integral of 3x squared dx plus the integral of 2x dx minus the integral of negative 5 dx. And here is where I want to introduce you to a new rule. So I'm going to copy this to the next slide. Okay, so I've copied this to a new slide here, and I want to introduce you to this rule here that says, down the bottom here, which says that if you get the integral of two expressions added or subtracted, then it's equal to the integral of the first expression plus or minus the integral of the second expression. So here I've got three expressions along here, 1, 2, 3, but you get the idea. I was able to break up that one expression into three separate integrals there. Okay, so that's an important part of what we're doing here. Okay, I've got one too many negatives there, by the way. Okay, so let's look at each bit individually. So this equals, okay, so we've got 3, we raise the power by 1 over that same new power, plus 2, raise x to the power of 1 by 1 is x squared over that same power is 2, minus the integral of 5 is 5x, and at the end we've got plus c. We don't have to put plus c for each individual bit, but we need to put the plus c at the end. So the 3's cancel in the first one here and here, x cubed, cancel, cancel, plus x squared, minus 5x plus c, and there's our integral. Next rule I want to discuss is this little one here. Integral of k, which is a number, constant, times f of x equals k times integral f of x. What does that mean? Well, if we had, say, the integral of, an integral of, say, 5x squared dx, I can take that 5 out the front and say it's 5 times the integral of x squared dx, which would be 5 times x cubed, raise the power by 1 over the new power. Okay, so that would equal 5x cubed on 3. So when you've got a constant out the front of a function like that, that 5 can pop out the front, and we use that all the time when we're doing integration. I want to introduce you now to another new rule, and it deals with a situation we've got. In fact, it involves the rule I just mentioned and a new rule. Let's just, before I go and look at the new rule, let's just start this question off. So, based on what I just showed you, I mentioned that if we've got 4 there at the front of a function, we can put that 4 out the front, okay, and go 4 times the integral of 5x minus 2 to the power of 3. So that separates the 4 out. Now, how do we do this integral of 5x minus 2 to the power of 3? Look at this rule here, guys, down the bottom right-hand corner here. Let's take it slowly. So it's the integral of something x plus or minus something to the power of something dx. So let's follow it through. So if you look at the top of the rule there, okay, if you look at the top of it there, it says repeat the bracket. Sorry. In fact, we should put our 4 there because we've got that out separate. So now we're applying the rule to this part here, and what it's saying is keep the bracket the same. So 5x minus 2, and raise it by 1. That's where the n plus 1 comes in. Okay, so n, we're now raising it by n plus 1, so it goes to 4, over okay, and then here we're told that it's the coefficient of x, so the number in front of the x in the bracket. And you'll notice the number in front of the x in the bracket is 5 times the new index, which is 4. Okay, so see if you can follow that rule. The antiderivative of ax plus b to the power of n, the bracket gets raised by a power over the coefficient of x times the new power. Okay, so I can see straight away now that I can actually cancel those 4's, which is handy. So I end up with 5x minus 2 to the power of 4 over 5. Okay, next one is 6 minus 5x to the power of negative 3. You can see there I've got that rule that deals with this sort of situation. If you like, in fact I should have, I forgot to put our integral sign in here. So that, and dx. In fact, you can change this if you like. Fits in better with the rule. Negative 5x plus 6. I'll change it back at the end though, but just to make it look a bit better. For using the rule, we can change it to that. And remember our rule says to integrate this, we take the existing bracket, okay, which is negative 5x plus 6, n plus 1, okay, raise it by a power, so it becomes negative 2. Remember, raising negative 3 by 1 is negative 2, over the coefficient of x, which is negative 5, that's our a value, down the bottom right hand corner there, multiplied by new index, which is neg 2. Okay, so we're going to get, and I might just change the brackets back now to 6 minus 5x. So 6 minus 5x to the power of negative 2 over negative 10. Fix up that negative 2 a bit. There we go. Okay, a few things that can happen here. To make the negative index positive, we take it to the denominator, so we leave a 1 up the top there, okay, and that's over negative 10 outside of 6 minus 5x squared, because it's changed from negative 2 to positive 2 as it's moved underneath. And really, when you've got a 1 over negative 10 situation, it's better to put it as negative 1 over 10. It's the same thing, 6 minus 5x squared. Okay, who picked up my mistake? Yeah, negative 5 times negative 2 is positive 10. So positive 10 should have been there. You don't need to put positive 10 really. But just rub those negatives out because I couldn't do negative 5 times negative 2 properly. There we go, there's 10, which means that was 1 over 10. Notice the back of the book just leaves it as, what is it, 6 minus 5x to the negative 2 over 10. So that's alright, either way. I suppose sometimes if it's expressed as negative indices in the question, it's okay to put them as negative indices in the answer as well. So there we go. That's the end of the first video, part 1 of integration, anti-differentiation. So look forward now to part 2.